logic, probability, and patterns. Solving 3 mathematical Brainteasers mathematical puzzles do more than just test arithmetic. They challenge our intuition and force us to look past surface-level patterns to find underlying truths. Below are the solutions to 3 distinct challenges involving naval strategy, logical deduction, and algebraic patterns. The Admiral's Dilemma. Single ship versus 2 ships in this scenario. A Navy admiral must choose between 2 strategic options to ensure a mission's success. Option A, send 1 ship with a success probability of $P. Option B, send 2 ships, each with a success probability of P/$2. The mission succeeds if at least 1 ship is successful. The solution? Option A is always superior. While intuition suggests that having 2 chances is better than 1, the math proves otherwise. To understand why, we look at the probability of failure. If we choose option B, the mission only fails if both ships fail. If each ship has a success probability of $P, where P equals P100, then each has a failure probability of $1 P/$2. The probability that both fail is $1 P/$2. Therefore, the probability of success for option B is $1 1 P/$2 equals P\P24 since P\P24 will always be less than P, the single ship. Option A provides a higher mathematical certainty of success. Why this matters? This puzzle highlights a common cognitive bias where we overestimate the benefit of splitting resources, failing to account for how reducing the individual probability of success impacts the overall outcome. The Oracle Test. Identifying randomness versus deception, you are faced with 2 oracles. Randy answers yes or no completely at random. Rando randomly decides whether to tell the truth or lie for each individual question. The solution? You can distinguish them by asking self-referential questions. The key is to find a question that forces a specific response from a person who is intentionally trying to be truthful or deceitful, but fails when faced with a logical paradox. Ask the Oracle, are you answering this question truthfully? Rando, the liar/truth teller. Whether Rando decides to lie or tell the truth, the answer will always be yes. A truth teller says yes. A liar, attempting to lie about their truthfulness, also says yes. Randy, the random. Because Randy is purely random, they will eventually answer no. By repeatedly asking this question, the moment you receive a no, you have identified Randy. The bad maths pattern. Algebraic truths. A student named Johnny noticed a pattern in subtraction. $5,548, 5489 equals $59. He noticed that by canceling out the middle digits, he arrived at the answer. He tested this on a general form, xxyz xyzw equals xw. The question is, how many of the digits in the new calculation, x, y, z, w dollar, are the same as the digits in the old one, $5, $4, $8, $9? The solution, only 2 digits, z dollar and w dollar, remain the same. To solve this, we convert the digits into an algebraic equation. 1100x plus 10y plus z, 1000x plus 100y plus 10z plus w equals 10x plus w $. Simplified, this becomes 90x dollars 90y equals 9z plus 2w $. Through logical deduction. For the equation to hold, w $ must be a multiple of 9, either 0 or 9. If w equals 0, then z $ would also have to be 0 to satisfy the equation, but the digits must be distinct. Therefore, w equals $9. Plugging w equals $9 into the equation, 9z plus $18 must be divisible by 10. We find that z equals $8. This leaves us with 90x dollars, 90y equals $90, or x equals y plus $1. While x dollar and y dollar can be various digits, such as 5 and 4, the only digits guaranteed to match the original problem, $5, $4, $8, $9, are z equals $8 and w equals $9. Conclusion: these puzzles demonstrate that mathematical certainty often contradicts human intuition. Whether through probability, logical paradoxes, or algebraic proofs, The most reliable path to a solution lies in rigorous analysis rather than pattern recognition alone.